this column here, listen to me first, just listen to me. This column that happens to be the column for x, since you are solving for x, all you need to do, you are going to replace it here with these values here. But every other value here remains constant for this variable. Then you look for the determinant. If you are solving for y, here will be 2, 1, 1. Then you replace this coefficient here of y with these three variables here. That is how to solve for y. So if let me start by solving for x. What I need to do, since I am solving for x, here is going to take 3. The next coefficient is going to take 0. The next one here is going to take 0. I am done with this. Then every other one remains the way it is. That is 1, minus 1, 2, 1, minus 1, and 1. Then you look for a determinant. That becomes your determinant of x. If you are looking for a determinant of y, here remains 2, 1, 1. Then here for y, you have to replace it with 3, 0, 0. Then this other column still maintains its coefficient. That is for the determinant of y. If you are to solve for a determinant of z, here remains 2, 1, 1. Here also remains 1, minus 1, and 2. Then the z you are solving for will take care of these parameters here.
Yeah.
Who don't understand what I'm explaining? I don't understand signify. We've gotten our overall determinant. I told you that the formula is, if you are looking for x, it will be the determinant of x all over the overall determinant. If you are looking for z, it will be the determinant of z all over the overall determinant. Likewise, if you are looking for y, it will be the determinant of y all over what? The overall determinant. The first step we took was to solve for what? The overall determinant, which we got 3. Keep it aside. Now the question is, look for the value of x, y, and z respectively. For me to look for the value of x, since it is x I am looking for, I have to replace my equality values with z, with x here. Look at it here. This is 3. So here is going to be 3. Here is going to be 0. Here is going to be 0. Then others here maintains their coefficient. This is 1, this is 1, this is 2. This is 1, this is 1, this is 1. Look at it here. 1. The next one, minus 1. 2. Go to z here. The coefficient is 1. Look at the 1. The next coefficient here is minus 1. This is the minus 1. The last coefficient here is what? Plus 1. This is the plus 1. Then you look for a determinant. That serves as your determinant of what? X. Once you get your determinant of x, you can now come here and say the determinant, the answer you got divided by 3, which happens to be the overall determinant. That gives you the value for x. If I'm looking for y, this is what I will do. Permit me to claim this. I am looking for y. Since I am not looking for x, all the coefficient of x maintains, it remains. That is 2, 1, and 1. Since it is y I am looking for, I have to replace the coefficient with my equality values. 3, 0, 0. Then my z maintains its coefficient, which is 1, minus 1, and 1. You look for a determinant. That serves as your determinant of y. If I'm looking for z here, I'll maintain this coefficient of x and y respectively. I'll only swap the coefficient of z with my equality values. Then you look for your determinant. That serves as the determinant of z. So that once you've gotten it, you now divide it by the overall determinant. That will give you a value for z. Who don't understand this explanation? Self-explanatory. So let's start like this. Let's look for a determinant of x. Let's start by looking for a determinant of x. So you have to give me your matrix. Replace the coefficient of x by what? The equality values. While other coefficient maintains its terms. Then you look for your determinant, which we did last week. Your 3 by 3 determinant. The first thing I expected you to do is to get me your determinant matrix this way. Fill in the elements. Fill in the elements since you are looking for x. So here is going to be 3, 0, 0 because we are looking for x. So change the coefficient of x to give you these values here. Why Z and Y maintains their individual coefficients. Then you solve for the determinant. That is what I'm expecting you to do. Who is done? Okay, while you are trying it out, let me also be working mine out here on the board. Clean this. So what I'm going to do is, I am starting with determinant of x, which is going to give me this way. I am looking for a determinant of x. As such, the coefficient of x is going to take my equality values. That is 3, 0, and 0. Then my coefficient of y remains. I have 1 here, I have -1, and here I have 2. The coefficient of z remains. That is, I have 1 here, I have -1, and here is also 1. From here, I can look for my determinant. Take note of the sign. Positive, negative, positive. So with respect to the first row, I'm going to pick the first element of the first row. That is 3. Then what next? I'll get rid of the row element 3 belongs to. I'll get rid of the row, or the column rather, element 3 belongs to. What is left is known as my minus. That is -1, -1, 2, and 1. -1, -1, 2, and 1. You go down to the second element of this row. That element is 1. Look at it here. You get rid of the row that element belongs to. Get rid of the column that element belongs to. The minus you should be having there. 0, -1, 0, and 1. You go down to the third element. Look at the third element here, which is 1. You delete the row to which that element belongs to. You also delete the column to which that element belongs to. What are the elements remaining, known as your minus? 0, -1, 0, and 2. Then you solve for your 2 by 2 matrix. I've gotten my answer, signify. I've gotten the answer, signify. None. Let's be fast about it. Remember, if it happens to be exam, you won't have the whole time to yourself. Try it again. Shouldn't be -3.5. Yes? You got 3? As the determinant of x. You've gotten 3. So the final answer for x will now be determinant of x, which is the 3 you've gotten, divided by the overall determinant, which is also 3. And that will give you 1 for x. That will give you 1 for x. So if you solve this determinant here, for this determinant of x, it should give you 3 as your answer. Once you've gotten 3, you can now go back to the formula. Determinant of x, which is the 3 that you've gotten, divided by the overall determinant, which is also 3 when we solved it. So 3 to 3, that gives us 1. You go back again and do for y. All you need to do, replace the coefficient of y with your equality values. Other parameters, other variables, that is x and z, maintains their coefficient, taking into consideration the sign. Very simple. What is it? You don't understand what I'm saying? What is the challenge? Are you true? Oh, yes, who is asking question? All right. The overall determinant. Okay, let's start like this. For your first minus, what are your first minus? Your first minus.
The second 2 are 0, so you only solve for the first figure.
The second?
The second and the third figure, when you try to solve them, they are 0.
Is it true? Okay, so we are just working with this here.
So we're only working with this.
Okay, so here it's going to be 3 into -1 times -2. Minus, then -1 times 2 give you -2 on its own. So -2. That is plus now. So at the end you now be having 3 into 1 times 2.
1 times
Minus 1.
Thank you. Good. Minus 1 there. Or is it minus 1 or plus 1?
Minus 1 plus
minus 1 plus
Minus 1 plus 2.
Yes.
That will give you what? 1. 3 times 1. Because the formula is the leading diagonal. The leading diagonal multiply it minus this other diagonal. Minus 1 times 1 will give us minus 1. Then minus 2. Which will give us minus 1 plus 2. And that will give us 1. 3 times 1 will give us 3. That is the overall. Are you still confused?
Yes, sir.
You're okay now?
So,
Hold on. Let me.
so the equations of above is plus minus plus, right?
Plus minus plus, yes.
So the values that we get after the after we solve what's in the determinant, it's supposed to be added to each other, not right.
We are not looking the other side of minus plus.
Okay, so,
We have nothing to do there.
yes, what I'm trying to say now is that
Okay.
minus 1 times 1 is minus 1.
Good.
Then 2 times minus 1 is minus 2.
Yes.
But we are adding the figures together. We are not.
No, the leading diagonal minus this other diagonal. Look at the leading diagonal here. Is it not like this? Minus 1. Is it not?
Yes.
Minus. This one is a constant like that, right? Minus 1 minus whatever I have this side happens to be minus 2. That is minus 1 times 2 give us minus 2. Then what of this minus? Oh, expand it out. Minus 1 plus 2. That gives us 1. Good. Who is done with the value for y? Oh, if I wait for me to tell you to start it. 5. Well, what is the determinant for y? Just the determinant for y. You got 5. 5.
Yes.
So if you're having 5 divided by the overall determinant, that happens to be 3. 1 point something. I need confirmation. You'll be in class with other students. They'll be answering questions of what you've done last week. You sit down and fold your hand. It's not encouraging. Who is having minus 2? Who is having minus 2? You got minus 2? That should be the answer. I don't know those of you having 1 point something or you got 1.
5 divided by overall.
Are you sure the determinant is 5? That is another question.
Determinant is minus 6.
That should be the consideration. Are you sure the determinant for y is 5 first? All right. Those of you standing, we have 6 here. Over here, you can stand for 1.5 hours. Those of you standing, we have 6 here. If you are done with y, you don't need to wait for me to tell you to solve for z. Try it out. Yes.
If we are putting for the y, if we put this, well, are we still going to put this constant minus?
No, it has the variables doesn't have minus sign there. I told you everything you are doing.
No, they are talking about.
Wait, no, here, not this is what you are looking at. This is what you are looking at, not the sign itself. The determinant of y is what? Then the overall the value for y is what? 3. All right, I will confirm that. Are you true? What is happening? I'm not doing anything. Are you done? Remember, this is not an exam. Just try your possible best to do something. As you are doing something, even if you are not doing the right thing, it motivates you than coming here to fold your hand looking at others. There's no how you try this thing that from the beginning to the end, even one step you won't get correctly. But by the time you fold your hand, you're not helping yourself, please. Your determinant for Z, you got what? 3? Yes, that should be the determinant for the overall determinant. The value for Z should be 3. Alright, please and please, I won't waste the whole time here. That happens to be, that is just take home for what we missed last week. But permit me to, let me just see how far. I'll keep quiet. I won't say anything. WAEC question 2014. WAEC question. Do I have WAEC students here? Good. WAEC, so you see I'm trying to balance the class. The one we just did here happens to be JAMB question last 2 years. Now WAEC question 2014. Just try it out. Then we'll move down to what we are to do for this week. Plane geometry. Under plane geometry, we have a lot to do. We're talking about polygons. We'll talk about angles. We'll talk about lines. We'll talk about alternate angles, corresponding angles, transversal line. We'll talk about all the polygons that is expected of you to know. From triangle to quadrilateral to pentagon, hexagon, heptagon, octagon, nonagon, and decagon. We should be looking at all these. That is what this topic is talking about. Plane geometry. We are looking at plane shapes. Not your cube, your cuboid, your sphere. No, those ones are under what? Solid shapes. So we have a lot to do. So please, let's try this out. The other question, keep it aside. Take it and use it to get idea into solving this. So every one of us should be on this now. On this now. Solve, let's get the question. Solve the following equations simultaneously. Solve the following equations simultaneously using the determinant method. Solve the following equations simultaneously. There's an instruction there, using the determinant method. This question goes for 15 marks. Just one question, 15 marks. Solve the following equations simultaneously using the determinant method. Let's get the equations now. Equation 1, 3x minus y. This is what we have here. 3x here minus y minus z is equals to minus 2. For equation 2, x plus 5y plus 2z is equals to 5. The last equation, what are we having? 2x here plus 3y plus z is equals to 0. Solve simultaneously. Start, look for your determinant first, the overall determinant. Emmanuel, we have 6 here. We have 6 here. Don't stand. Over to this side. This is the gap between the 6 and the. Oh, no wonder students are running away from. Okay, I see. So someone will join you there. Be your brother's keeper. Manuel, we have 6 there instead of standing. On the gap, the gap is 2. Can you manage it? So over there, my friend, can you manage it? Too wide the gap. Can you manage it? Okay, we have 6 there. Solve the following was equations simultaneously using determinant method. I told you the first thing you need to do is to look for the overall determinant. So your matrix determinant should be 3 minus 1 minus 1 for the first row. For the second row, that should be 1, 5, and 2. And for the last row, what are we having here? 2, 3, and 1. Then you solve the determinant here for a 3 by 3 matrix. That should serve as your overall determinant here.